Welcome to Maths with EJD. This is my second video on integration, and here we'll consider integration of polynomial functions. Okay, you remember we under differentiation we once looked at how to differentiate polynomial functions, and of course my first video on polynomials also. My first video on integration, we saw integration as anti-differentiation, and we discovered that if you have an original function y and you differentiate it, you're going to get a particular result. You get the integral. But if you get a derivative, sorry, and by the time you integrate that derivative, you get back the function you started with, So now let's see the rule that we applied in doing that. So talking about integration of polynomial functions, right? You already have an idea what polynomials look like. They are functions like f of x, or of course, y is f of x, right? Equals maybe a particular coefficient, let's say C1 with maybe x raised to power a particular value n plus C2 x raised to power n minus 1, and so on and so forth, all this up to say some particular Cn x raised to power 0, until you have a constant. So that's generally the idea of a the idea of a polynomial. Okay. So here we just take this as a general form of a polynomial. So given a polynomial of the form y equals ax raised to power n. So you simply have integral of y dx. This y now, you are integrate y dx means you are integrating with respect to x. Okay. And then that means you also have integral of ax raised to power n dx with respect to x again. And since it is a polynomial, like I explained the other time, the result is usually you take which is a constant, then you have x, then the power of n now is increased by 1, so you have n plus 1, and then you divide by the new power, which is n plus 1 also. Of course, then you add an arbitrary constant c, and we saw a good example of this arbitrary constant in the first video, right? Where after differentiating the function, the constant part went to 0, and by the time we integrated, the constant was missing. So, and then we had to add c, which is an arbitrary constant. And of course, we could only get that original constant back if we had extra information like y of 0 equals 7, But since you won't always get that extra information, then anytime you don't have the extra information, you have to add c or k or whatever you want to add as an arbitrary constant to complete the expression. Okay, so we have our first example. I mean, the rule is just straightforward. We want to evaluate integral of x cubed plus 3x squared minus 4x plus 6 with respect to x. That's what the x means, like I said. So, of course, this is an integral of a polynomial function. So, x cubed would mean you have x raised to power 3 plus 1 divided by that 3 plus 1. Then 3x squared will mean 3x raised to power 2 plus 1 divided by 2 plus 1 minus 4x. 4x is 4x raised to power 1. So that's like 4x raised to power 1 plus 1 divided by 1 plus 1 plus 6x raised to power 0 constant. 6x raised to power 0, that's 6x raised to power 0 plus 1 divided by 0 plus 1. Don't forget to add the arbitrary constant. Without the arbitrary constant, your answer is not complete, So you can lose marks for forgetting the arbitrary constant. So don't you ever forget. All right. Okay. So by doing this, immediately you do this, the integral sign disappears because you have done what the sign is meant to do. Okay. So now you just tidy things up. So you have x raised to power 4 divided by 4, 3x raised to power 3 divided by 3, minus 4x, this now, minus 4x raised to power 2 divided by 2, plus 6x raised to power 1 divided by 1, plus the arbitrary constant. And then you go further, and then you have x raised to power 4 over 4 is the same thing as 1 over 4, x raised to power 4. Then, of course, 3 cancels 3. So you have x raised to power 3. 2 goes there, 1, 2 goes in 4, 2. So you have minus 2x raised to power 2. Then, of course, this is 6x plus c. And that's so simple. That is how you integrate a polynomial function. So straight to the point. Okay? Of course, things can get not so polynomial sometimes too, right? For instance, you have this integral, the integral of x raised to power 4 minus 3x cubed plus x squared divided by x. So when you have an expression like this, if you look through, okay, it's still polynomial, right? By the time you divide through by x. So if you look through, you can see that x can divide everything at the top, and then you have something like this: x raised to the power 4 minus 3x cubed plus x squared, all divided by x. So you can just open all of that up. So the integral is still there because you have not integrated. You are still you want to tidy that up to make it easier to integrate. So you have x raised to the power 4 divided by x minus 3x cubed divided by x plus x squared divided by x. So 1x cancels 1x here. You have x raised to the power 3. 1x cancels 1x here. You have minus 3x raised to the power 2. X cancels x here. You have plus x. Okay. And now that is tidy enough for integration. So you can apply the rule of integration. Now that you know the rule, I'm not going through the motions again. So for x cubed, you know, that'll be x raised to the power 4 divided by 4, then minus 3x squared, that'll be minus 3x cubed divided by 3. Then for x, you have x raised to the power 2 divided by 2, then plus an arbitrary constant. Again, you tidy all that up. You have 1 over 4x raised to the power 4 minus x cubed plus 1 over 2x squared plus c. And that is the simple answer we're working towards, justice. So, I mean, that's all for this video. It's so straight to the point. So when you have polynomial functions, just increase the power by of each term, of each expression, of each part by 1 and divide by the new power you have. So that is the end of this video. Watch out for the next one. If you have not subscribed, make sure you do that. If you have subscribed and you forgot to press the bell button so you can always get alerts about new videos, please go and press the bell button, press all so you can always get notified. Thank you. See you in the next video.